Okay, let's talk about applying a function to parallel vectors or lists. Now, before we do that, let's quickly review creating a function. So the basic syntax for creating a function is like this. You give the function a name, you list the parameters, and then you put the expression. Now, this itself won't work. This will give us an error of some sort. Or just repeats back what we wrote. And the expression here can also have many statements, in which case you'd want to put brackets around the set of all of them. So you might write something like this. The parameter list here, but the expressions would go expression 1, expression 2, all the way down to here with some brackets around it. Okay. Now up here you can see, well, so remember that this gives me a vector. Let's just try that again. So this is going to give me a vector of elements from 1 to 10, like that. Okay, now, I tried something like this. I wrote, now usually this would be a function that was, like we might have like, okay, we might do the mean. I think it's the mean. 1 to 10. So we're applying the mean to this vector, and we get a result. The average of the elements in that vector. If I do CV of that same vector, it says it can't find that CV because CV is not a function that's defined by in R. Okay, so maybe we can use this symbol to create a function that we want. But anyway, it's not a reserved symbol in R. It's not already a function. Okay, so at this point it's just useless and meaningless. Okay, now if you look up here, I did something called SD, which you might recall is the standard deviation of these numbers, of this list of numbers, and this is the mean. We just did the mean of this list of numbers. So, well, let's just do the standard deviation just to see it. SD. Okay, so we get the standard deviation of these numbers is this result here. It means how spread out these numbers are. But anyway, it's a number. Standard deviation of these numbers is this number. So what am I doing here? I'm taking the standard deviation of those numbers divided by the mean of those numbers. Okay, now maybe that doesn't have any particular meaning to us, but we can do it. Let me see, do I have it still here? Can I just pull it up here? Oh, it's all the way back there. Let's see, no, there. Okay, so if I do it, I get a result, because that's the standard deviation, which was this number, divided by the mean, which was somewhere up here. And when we do that, we get here. Okay, so actually this has some meaning in statistics, this SD divided by the mean. It's kind of the standard deviation, and then divided by mean is kind of balanced by the mean. So if the mean is really large, then when you divide the standard deviation by it, it becomes quite small. So it means like the spread relative to the mean. Okay, but whether this has any meaning to you or not, this is a calculation we might want to do often, in which case we can create a function that will do this calculation always for us instead of having to type it out like this. And the way that we do it is we use this, where did I have it up here? No, here. I use this syntax here. So I write function, and then the parameters, and then how to calculate. And I can also assign this to a name, so I'm going to do that here. Like this. So I have, it's a function, and it takes a vector as its argument. And then what do we do with that vector? We're going to take the standard deviation of that vector and divide it by the mean of that vector. And when we're finished, we're going to assign the result to CV. So this then creates a function called CV. And now we can treat that CV as just like any other function. Like we did the mean of a vector, we can now do CV of a vector. We've created the vector, I'm sorry, the function CV. So we can do this, for example, and we get a result. In fact, we get the result we got up here because it's doing that calculation. We can use CV on any vector. For example, this vector. And it gives us a result. Okay? So this, by the way, this CV has a name. It's called the coefficient of variation. Let's see, can I write this down here? No. So it's called the coefficient of variation. And that's something that statisticians like to use. And you can see what the definition is. It's the standard deviation divided by the mean. So that's what the coefficient of variation is. But R doesn't have that function in its library of functions, but we just created it, and then we can use it. Okay, so that was just a quick review, but we're talking about applying a function to parallel vectors or lists. Okay, let's see. So I create a function here called ode, and it takes two arguments, and then what it does is it sums the first argument with I over 100 times 6. So this is, P is like the present value of something, and this is the interest. So maybe you borrow $100 and interest is 10%. And the question, or this is supposed to give you how much you owe after 1 year. So the interest is 10% per year. It's very simple, not very good function, but anyway, very simple for showing this situation. So for example, if I put in 50 and 10, I'm talking about you borrow $50 and the interest rate is 10%, then at the end of a year you owe $50 plus 10% of $50. So you have to pay 10% of $50 is not right. Okay, let me try it this way. I redefined it, so its sum is P, the sum of P and P times this I over 100. It didn't really make sense before. Okay, so I do 50 and 10, so 10% is the interest rate and $50 is borrowed, so at the end of the year I have to pay $55, right? It's $50 plus $50 times 10 over 100. $50 times 1/10 is 5, so that's 50 plus $5, $55. Now, suppose I try to do this with a vector as input. So suppose I try this. So I'm still using the ode function, just like I used it here, but my two arguments are here is one argument, and here's the other argument. So the two arguments are vectors. This is a vector, consists of 100 and 1,000, and this is a vector. So I'm hoping what I'd like to get out of this is that I'd like to get two cases. One is the case where I borrowed 100 and the interest rate was 5%, so what do I owe? And the other is that I borrowed 1,000 and the interest rate is 10%. So I'd like to get two answers for those two scenarios, but it's not going to do that. When I enter it, it gives me some weird answer, which is not what I wanted. So instead, to handle this, we use the mapply function like this. So this will apply this function, and these are the arguments for this function. So since ode was defined to take two arguments, two inputs, then I have to give two inputs over here. If ode was somehow defined to take three inputs, maybe something here, and something here, and some other thing, then over here I'd have to have one thing here, another thing here, and then a third thing. Okay, so the way that you use mapply is you mention the function first, and then this is going to be applied to the arguments here, and the arguments can be vectors in this case, and it will still work. So let's see if it really does work. Okay, so that is right? Because I wanted to say I borrowed 100 at 5%, and I borrowed 1,000 at 10%, and that would give me these two answers. Now one other thing, I tried to do this more simply. Instead of defining owed using this word sum, the first way I did it was like this. So when I was making this example up for this video, I first tried to do it like this. It's the same thing. It looks like it's the same thing. Owed equals function pi, O equals function pi. And then I said this sum, instead of sum, which is sum of p plus that, this would be even the more natural way to write it. So I tried it, and I did just like I tried this case here, and I was hoping that it wouldn't work and I would get something like this, but it did work. I got something like this. Let's see. If I do it now, I want to do this, and I remember it didn't work when I used the word sum, but how about now? Okay, now I get the same thing as when I used the mapply. So I was confused. I was trying to make an example where it wouldn't treat the vectors properly, but it was. And the reason is that the plus operator already sort of handles vectors. So once you put in the plus operator, plus sort of vectorizes it already. So you wouldn't really need to do it in that case. You wouldn't need to do the mapply. But in other cases, you might have defined it this way instead of using the plus operator here, wherever it was here. You might have used this word sum instead, and that doesn't automatically vectorize. So in that case, or in any case where you don't automatically have things vectorized, then you would do it this way. Then when you want to vectorize it, you'd say mapply owed, comma, and the other things like this, the other arguments. Remember that if I take, just to give you an example, let's say the plus operator again. Let's do C 1 through 10 plus C 1 through 10 again. So what does this give me? The plus operator does automatically vectorize, so to speak. So I have a vector here and a vector here, and it's going to add them as vectors. So adding them as vectors means I have this vector is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this vector is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And when I add them, I'm adding the first elements together, then the second elements together, and so on. So I'll get this. So when I add 1 plus 1, I get 2. When I add 2 plus 2, I get 4, and so on. Okay, I hope this is clear. So, the plus operator already vectorizes things. Okay, or it knows that to treat this like a vector and this as a vector, or it does treat this as a vector and this as a vector, and adds them. Okay.